Hey coders, I am here with a quick deep dive into the backbone of all your favorite apps. Have you ever tracked your latest biryani order from Swiggy right on your phone screen? That seamless real-time tracking magic is built on simple concepts, starting with Python variables. Think of a variable as a perfectly labeled storage container holding your crucial data, just like a labeled jar in your kitchen pantry. In Python, creating one is incredibly straightforward. You just give it a name followed by an equal sign and its initial value. The best part about Python is its dynamic nature, meaning you don't have to pre-declare the data type like in some other languages. You can jump straight into coding without worrying about type declarations upfront, which saves tons of time. To truly grasp this, let's see a quick setup, like assigning the city name Hyderabad to a variable we call city. Then, running a simple print command on that city variable instantly displays our location. But before we explore the powerhouse use cases, we must cover the non-negotiable rules for naming these containers. Seriously, breaking even one of these rules will cause your program to immediately throw an error and crash. Imagine the power to predict a massive traffic jam on the OR before you even leave your house. That is what we are building toward. All right, let's talk about the golden rules for naming your Python variables, so your code stays clean and functional. Rule number 1 states your variable name absolutely must begin with a letter or an underscore symbol. It is strictly forbidden to start a variable name with a number. So this one fare example simply will not work. Conversely, something like total fare set to 150 is perfectly acceptable and follows the best practice. Moving on to rule 2. You must avoid using any spaces or most special characters within the name itself. If you need to separate words, the underscore is your designated tool, which is why we use snake cases, like username. This convention keeps the code readable and avoids any potential syntax confusion down the line. Our third crucial rule addresses case sensitivity, which trips up many beginners starting their journey. Remember that Python treats uppercase and lowercase letters as entirely different characters. So age is not the same as age. If you intended to store your age, using the wrong case will reference a completely different, likely non-existent variable. The final rule is to steer clear of reserved Python keywords that are already spoken for by the language itself. Words like if, for, or while have built-in meanings and cannot be repurposed as variable names. If you are ever unsure whether a name is reserved, a quick search online will immediately clarify its status. As a pro tip, always aim for descriptive names. Labeling your variable auto-ride cost is much clearer than just C. Think of it like labeling everything in your life. Good labels prevent massive headaches later on. Now, what happens if you try to name a variable using a reserved word like class? Boom! You will instantly get a syntax error because Python needs that word for its object-oriented programming structures. Mastering these 4 simple conventions is the gatekeeper to writing stable, scalable Python code. Let's leave the theory behind because variables truly power the dynamic world we interact with every single day. Consider use case number 1, tracking chaos during Hyderabad's notorious rush hour traffic. We can store the current density percentage in a variable like current traffic equals 75 using an integer. We'll also store the destination route itself, perhaps as a string like route equals high-tech city. And critically, we might track if the weather is impacting the flow with a Boolean, say is raining equals true. Here is the real-time magic. During a sudden monsoon downpour, the code simply updates that traffic variable upwards by 10 points. Your navigation app then instantly uses that updated value to push an alert. Heavy jam ahead. Next up is use case 2, which I know many of you use daily, managing your food delivery budget on Swiggy or Zomato. Your monthly earnings might be stored as a float, such as income equals 5,000.5. Oh, rupees for this exercise. Then, the cost of that tempting biryani order gets stored as an integer. Maybe order cost equals 250. Python then checks instantly if you can afford it by comparing them. Affordable equals order cost city income, which resolves to true. Now, what if the delivery surge pricing kicks in and the cost jumps by 50 rupees? With variables, you change only one number and the entire affordability check recalculates instantly, preventing overspending. There is absolutely no need for hard coding the old price, which keeps your budget safe and sound. Our third practical example involves building a basic weather forecaster, perfect for the Telangana heat waves. We start by grabbing the current temperature, perhaps temp equals 35.5 stored as a float. The application then uses a simple conditional check based on that temperature value. It will assign the alert level as high if the temp is over 30, otherwise it defaults to normal. This beautifully demonstrates how variables feed logic gates to make smart decisions in your code. In a future video, we will hook this up to a live API to update the temp variable automatically in real time. Every single dynamic application you use, from finance to gaming, relies on this simple principle of updating stored values. These powerful tools allow your apps to react intelligently to the ever-changing world around them. Whether it's a changing stock price or a shifting traffic density, variables are the key to that responsiveness. Take a moment to think about your favorite app and how many dynamic values it must be tracking right now. It is all just a collection of well-named variables being updated in the background. So there you have it. Python variables are not just abstract concepts. They are the foundation for all real-time application magic. We covered what they are, the 4 essential rules you must follow, and saw them in action tracking traffic and budgets. Now it is your turn to put this knowledge directly into practice with a small challenge. I challenge you to code a simple Hyderabad commute calculator right now using the concepts we just learned. Make sure you use variables to store your starting point, your destination, and the current estimated travel time. Once you have your working code snippet, drop it right down into the comment section below for everyone to see. If this quick tutorial sparked your coding curiosity and helped you understand the basics, please show some support. Hit that like button, subscribe to the channel, and make sure you ring the notification bell. That way, you will not miss our next video where we explore the world of Python strings and more real-world hacks. Keep practicing, keep experimenting, and I will see all of you back in the code world very soon.